All right. Well, cellulose insulation is long tried and true product when it comes to blown in insulation. But did you know it can also be made into rigid batt? I have personally used it on at least two project retrofits over a decade ago, but I'm still surprised on how many people are unaware of it. So please join us as we go through this session to learn more about a sustainable batt insulation that can be made locally or regionally with recycled material, low embodied energy, and in a much easier and more do-it-yourself manner for new construction and renovation installations. Before we get started, I do want to give a huge shout out to one of our platinum sponsors, Rheem, with their ProTerra system. These are heat pump water heaters with a limited tax credit that will end at the end of 2025 at this point. And these are some of the highest efficient water heaters you can get on the market, up to 400% energy efficiency, taking heat right out of the air. They have hybrid systems that have backup electric resistance, or they have 120 volt plug and play, easy swap out gas systems as well. So check them out over at greenhomeinstitute.org/REAMHPWH. All right, well, welcome everyone to All About Solid Cellulose Batt Insulation that is do-it-yourself friendly. This course brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. Like all of our courses, this course is approved for multiple continuing education units, including 3 of the 5 pillars in our Certified Green Home Professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out the 5-digit CEUS code sent to you at the end of the session as long as you're here for the entire CEU hour. And also check out the 5-digit ICC code that will be sent to you as well if you're reporting your International Code Council. And we're very grateful for Energy Smart Institute for helping sponsor these CEUs. So check them out for your Energy Rater training needs. So with that, I will hand it off to our speaker today, Robert DeVries Newell. It's glad to see you on. Glad you could join us. So welcome, and please take it away.
Hey, thanks, Brett. Really appreciate it. Yeah, so as you had mentioned, we talked about this as being kind of a new product, but we've got to take a look at where we came from to get here. So it's kind of like that latest singer that you just heard about that's an overnight sensation. History goes back a little bit further than the last few years. So the U.S. Forest Products Lab, they actually came up with a batt material kind of like this. Is the first kind of biomat that the Forest Products Lab made in the late 90s, mid 90s. So our journey actually started 20 years ago. For this type of process, we looked at manufacturers that were in France, and we looked at manufacturers that were in Italy that were making, it's a non-woven product is what we're going to be talking about. And we ended up purchasing some equipment from Italy. The reason we're telling people is because everybody here liked the Italian food better than the French food when we were exploring these options. So that's our story, and we're sticking with why we had the Italians come in. So the line comes in, it takes 6 months to put it together, another couple months to work it out, and then we had to learn how to run paper through it because paper was never a material being run before. So now that we started to make some product, we needed to start figuring out what kind of densities we could make it at, what kind of fiber blends we could use. What would you use it for? Is it going to be simply acoustical? Is it going to be thermal? What are the moisture characteristics? So we started making samples for testing. because all of your materials need to be tested. Once we started figuring out what we could do and what we couldn't do, we decided to start doing batts and blankets because the core business was cellulose insulation, primarily for walls and for attics. So we wanted to complement that. If you're going to be used in construction, you need to have some type of a standard, and you have to have some test methods to be able to prove to the building authorities that you have a material that's going to be okay and proper to be used in a home. So we went to ICC and looked at some other materials that were similar, a poly batt, cotton batt, some other fiber batts, and we came up with our own listing. There are other people making batts and blankets, but there's only one that's making a cellulose batt and blanket. So some of the testing that we looked at are the thermals. Obviously, you want to know the R value of it. You need to know what the density is going to be. Odor, it's always good to make sure something doesn't smell when you install it in a home. And a lot of these came from C739, which is the specification for cellulose material. Let's take a quick look at a couple of the tests. So the one main test that we always like to look at, especially when we're talking cellulose, which is essentially ground paper, is fire. It's typical that fire and paper don't get along well. So this gentleman is prepping the Steiner tunnel or the E84 tunnel for fire testing. And this is what happens. The material gets put on the top of the tunnel. There is a gas flame. Those are 3/4 inch pipe fittings that have a gas flame that will go for the next 10 minutes. That flame goes down the tunnel, and that's where they get their flame spread rating from. Then also at the end of the tunnel is some optics that measure the smoke develop. So now you have your flame spread and smoke develop. And those numbers are what are going to let you know whether or not you can leave the material exposed in construction or not. So when it's done, you see the batts right where the jets were. It essentially burns through after 10 minutes. But as you can see, the other sheet that the gentleman has flipped over, it simply has smoked the top layer. The next thing what we want to look at is our density, and how does our density play into the trapping of air, and the trapping of air goes into the effectiveness of thermal insulation. So we had several different types of materials put into a frame. One uncommon material in the middle of the frame, or one that doesn't match. They all look fine. They're all well placed. But under thermal infrared imaging, we can see there's a significant difference with the fiber structure and the density of the materials. So now we have that going for us. So how does this stuff get made? As I said, it's a non-woven material. And basically here are the steps. You take the fibers. Now those fibers are typically cellulose. They can be cotton, as we'll see later. Recycled carpet fiber is a possibility. But then they're blended, and what they're blended with is what's called a bicomponent fiber. So if you're familiar with, say, hot melt glue, take a polyester fiber that has a very high melting point and then encapsulate it in hot melt glue. You blend those fibers in with the paper fibers, keep blending them till you've got a very good mix, form them out onto a pad, and then heat it. Now the heating is going to melt the outer jacket of that bicomponent fiber, and then when it cools, it will hold all of the fibers around it together. So this is the opening process. Cellulose fibers on the left and bicomponent fibers on the right are continuously broken up, opened up, Here is where we're experimenting with jute fibers. We have hemp in the process as well. We've made hemp batts. Whatever fibers you can think of, we're going to attempt to do something with. There's some of the bicomponent fiber. It's very small, very fine. Think of it as like pillow fill. Going through these machines get a little complex in their size and ability to blend things. And everything is carried by air. So everything is fluffed and carried by air, all computer controlled so that we know what percentage of what material is being put in. Then it gets put down onto a table. And now towards the bottom, you can just make out some of the material starting to come out as a thicker layer. And there you can see the thicker layer. That is all blended, ready to go to the oven. And there we see some more of the material. There it is starting to go into the oven, and you see this large conveyor belt. The conveyor belt top and bottom. As it runs through, it is now being compressed. It gets compressed to the final thickness and also heated. And then it runs the entire length of this oven to actuate all of the bicomponent fibers. Constantly watching the temperature, constantly watching the speed. And what you're seeing there is some cutoffs. There's guillotines that slice the edges off. And those bits of scrap will actually end up back into the cellulose production. They won't go back into the batt production, but they will go back into the cellulose production. So those are not wasted. And then the guillotine is also doing lengthwise. So whether it be 16 or 24 inch. One of the things that we like about this is that it is really not affected. The R value is not affected by compression. So we actually sell it as a 16-inch wide batt, even though in a standard 2x4 stud cavity, it's 14.5 inches. The compression does not affect the R value, but then also you can use it in steel stud without it being too loose. And the same with a 24-inch. And here you can see the final product coming out of the end of the last compression roll. Thicknesses. Anything down to 1/4 of an inch, and we've gotten to 5.5 inches. We do have a 5.5 inch batt for 2x6 walls. It's hard to get much further past that. We initially were using jute fibers to get the loft, but we've been able to perfect the method of teasing the cellulose correctly and getting the bicomponent fibers laid in correctly to get to the 5.5 inch thick. And then, of course, as the thicknesses change, densities are going to vary as well. And this is final product, the way it looks wrapped, the way it looks stacked, ready for install. So install, as you would a typical batt situation. As I said, they come pre-cut to the length of this typical 8-foot stud wall and to the width of either 16-inch or 24-inch on center walls. We also make blankets, 4x8-foot blankets for basement. Now, these gentlemen are using a touch and seal type straw can foam, which polyisosanurate is a glue as well as a foam. There are different methods. You can use a contact adhesive, and there is also Hilti pins that can be used if you want to mechanically fasten it. And the left picture by the gentleman's foot, you can see there's a 2x4 on the ground. So this happens to be the 1.5" R6 material. And what we suggest is that you lay a 2x4 on the ground for two reasons. First reason is you're going to pull that 2x4 out afterwards. And if some moisture, some water builds up on the basement floor, it doesn't immediately wick into the panel. Now, we have had situations where foundations have cracked or basements have flooded or something to that effect has happened, and the material dries out. As long as the water is not overly contaminated, the panels will dry out and the fire retardancy remains, because the borates that are used for the fire retardancy are locked in with the bicomponent fibers. So we do that just as a little assurance that if you get a little bit of water, we don't have an issue with it getting soaked up the wall. But secondly, the reason we suggest to do that is if you're building a new home and you can't afford to finish out the basement, but you have to make the energy code, this is a perfect way of doing that. You can get the insulation on the wall without having to stud anything out. No studding, no electrical, no drywall. You get the insulation on the wall. Now, later, when you want to come back to finish the basement, you can take a piece of pressure treated and slide it into that area below because you've already gapped that 1.5". Now turn the studs sideways to go to your top plate, and the insulation can remain in place to give its full value. You still have continuous insulation. You don't have to try to cut anything out where the studs are or anything like that. As we move forward in the codes, and if you go to the 2.5", which is an R10, you would just simply move that plate out a little bit further, but by no means are you going to have to go to a full 2x6 wall. It's very durable. Probably one of the hardest parts of this is the cutting of the batts and the blankets. You simply do not cut it with a utility knife. An Insul knife does work, but this is one of the solutions that we have found best is a masonry blade in a circular saw or a masonry blade in a angle grinder, and lay a board on the ground, follow where your cut line is going to be to cut it. You are not going to tear it. Once it's on the wall, and if it's glued or if it's mechanically fastened, it's going to be very difficult to get off the wall because the bicomponent fibers have really locked everything in. And that has been what we have found to be probably our most trouble spot, is the cutting of this material because of how tough it is. On the other hand, it's great resilience. You get a basement that is sealed up with the blankets. We know of families whose children have gone and played hockey and pitched baseballs and whatnot, and it simply absorbs into the pads. And they're also very happy to hear the sound absorption qualities as well. This particular panel, this 1.5" panel, has an NRC of 1. So there's a total absorption of reflected sound, an SAA of 1 as well. We had a client ask to have FSK or foil face put on more dense pieces. These are approaching 3 pounds per cubic foot. What's been on the wall is 2 pounds per cubic foot. And they wanted this foil face on there to be able to put in the rim joist. Acts as an air barrier. And it just has a much better finish to it. As I said, they were cut wide, the full 16 or the full 24, to make them be able to fit into steel studs as well. And more often than not, these are used in steel stud in commercial construction for their sound abilities. their ability to have that high density to absorb sound energy. This is a retrofit of a church basement rec room. They were able to cut the blankets the width of the steel W trusses, use wires to pin through, and it drastically reduced all of the echo that they had. It was a rec area for children, and cement floor, steel ceiling, block walls. You can picture the situation, or rather, I'd say you can hear the situation when you have a lot of kids running around. Um, very happy with this application. When it's finished in the basement, there are times when a homeowner doesn't even recognize or realize that it's installed. It basically blends in with poured concrete. What they do notice is the sound absorption. It's a very unique feeling to go into a basement that has this type of material on the wall, and the sound immediately, your mind lets you know that you are in a different space. It can also be used above ceiling tiles to help absorb sound from one office to the next. Again, that's where 24-inch pieces work well, because most grid systems are on a 24-inch centered system. This is a little bit of a different situation. We were approached by a company that was making poured concrete, precast poured concrete foundations, and they were using EPS as their insulation and required a thermal barrier over it. So this is where we were able to put in our blanket system over top of their EPS in their precast wall system. And what you're looking at is that corner of a corner burn test. And it succeeded. So what's coming up next? Foundation insulation is on the rise as the codes are increasing the amount of insulation required for the foundation. Sometimes it's not a bad idea to get it on the outside where you don't lose that real estate, but then also act as a drainage plane to help your damp proofing keep the water away from the foundation. So we're now making this material strictly out of recycled carpet fiber. So the goal here is to do as much recycle. We don't want anything, our goal is to have nothing less than 70% recycled material in whatever it is we're making. And this material has gone through the final testing of drain plane and dimensional stability and puncture resistance and the rest of that. Flooring underlayment. Just essentially take that same batt, only compress it down to 3/8 of an inch. And now you have a flooring underlayment that can go under hardwood floors or vinyl floors to help stop noise, that mechanical transfer of noise between floor and ceiling. Ceiling tiles. Here we put a scrim on it. You don't want to be looking at that checkered pattern of all of those bits and pieces. So compress it down, make a ceiling tile that's out of recycled material, put a scrim on it to match whatever color or whatever texture you want for the room. Same thing here with ductboard. Something similar to the rim band insulation that we had done, only it's much more dense, and it has an FSK facing on it as well for ductboard. Again, it meets the flame spread and smoke develop for plenum use. Acoustics is where we really excel. A lot of the material is simply used for the absorption of sound because it can be left exposed. It's not uncommon that these get put into panels, and the panels have a decorative scrim put over top of them, and they can either be hung on the wall of conference rooms, gymnasiums, We had a customer that did a project where they simply took 1x4s, made 2 foot by 4 foot frames out of the 1x4s, adhered the blanket, the 1.5 inch blanket to the frames, and then had the different classes that they had, grade school through high school, take fabric and draw on the fabric something that represented their class, and they wrapped each one of those frames in that fabric and then hung them on a 45 in the gymatorium, greatly reducing all of the reverberations in the room and making it a much more pleasant space and a decorative space that everybody had a hand in. The material can be molded. That is a trunk liner for a car. We've molded it for insulation around dishwashers. So there's a lot of potential with it. Cutting it with a water jet. It is a very solid material depending upon the density that you make it at. And with a water jet, there's not a lot of limitations to different shapes and pieces that you can make. Thickness is our challenge. This is a hemp batt. So we were able to get a hemp batt, an extremely thick block. Part of the challenge with hemp is getting the right feedstock. While hemp is talked a lot about, it's going in so many different directions. Sometimes it is difficult to get the fibers that we're looking to use. But we do have some sources, and it is well worth exploring. So here's all the different things that we've tried. Yes, prison mattresses was one of them, and casket liners was, in fact, one of them. The casket liner was a little creepy, I'll have to admit to that. But this is where we pretty much stayed. Office panels, a couple of local manufacturers in the Grand Rapids, Holland area would use our material in their office partitions, again, primarily for sound absorption. Insulation products, that is where we excel at, and that is where we try to move most of it. Packaging did not make it on the list. Packaging got us through COVID. When things like Blue Apron and the rest of those types of companies were mail ordering out food, we were working overtime to get them packaged materials that were insulated, but then also recyclable or compostable, so we didn't have a lot of waste. It's very satisfying to take recycled material and either recycle it or know that you have done something well with it before it does make it back into the landfill. So, moving forward, we've got a lot of new fibers to work with. The recycled carpet fibers turned out really well. As I'd mentioned, hemp is another one that we've been working with. Finding a balance between the products that we're making and the people needing them can be a little interesting at times. We're looking for new additives in that sense of how to make it potentially that could go exterior. One of my projects that I was working on and have now put on hold until I can get over some hurdles is an exterior above grade continuous insulation panel. It more than likely will not be primarily cellulose due to the hydrophilic nature of cellulose. But we do have other fibers that we can work with that are recyclable. Doubling the capacity, what you saw was one line. A couple of years ago, we actually added a second line. So we have doubled our capacity to produce these materials. And we're always looking for new places to put them, new ways to build them, and new things to build them out. And that, ladies and gentlemen, is my story.
Hey, great. Thanks, Robert. So I see a lot of uh, questions, and we're going to get to those in a little bit. Obviously, there's some other conversations we have set up here to specifically go over. I think one of the ones was just kind of going back again over what is it that is cellulose is made out of. And especially when it comes to the folks pursuing green building strategies, they're typically trying to review pre-consumer, post-consumer, what percentage of the product is pre-consumer, post-consumer. I know there's also bio-based certifications for things like that, if that's relevant or not. But can you just tell us, like, typically what these materials, what is the source material for this? I know you kind of went into it, but just explain it a little more detail. So,
Yeah, certainly. When you're embedded in it, sometimes you just say cellulose and you don't realize that that encompasses a lot.
yeah.
So you've got a lot of good stuff there, Brett. Let's start with the base material itself, the feedstock. Um, when I started some 20 years ago, newspapers were actually being read and printed yet. Um, Not so much anymore. We still get them. So we still have to look for other fibers. Now, people do not stop using paper. So cellulose is a generic term of paper. Um, More of it is now becoming post-industrial. Napkins, filters. We have an account where there are papers used in filtration systems for your air cleaner of your car, your oil cleaner, oil filter, that type of thing. So a lot of those that don't make the cut
Mm,
come to us. And then somebody that comes to pretty much everybody's door, and I think they're having some type of a special going on right now.
mm.
Um, Prime Days, I hear.
Oh,
We thank them for that because we are able to use the cardboard.
okay.
And what's nice is a company like Amazon, you may have noticed it on their package about greener packaging. In years past, there was a tremendous amount of adhesive and glues used in cardboard that we would shun away from using those materials. But now the production of cardboard boxes and bags and the like, they aren't using as many glues and chemicals as before. They're finding more natural starches and that type of thing to hold things together. So we're finding it very easy to take that feedstock. We're probably upwards of 50% of that now.
Mm,
So instead of relying on the old newspaper system, we are having more post-industrial. And you
mm,
had mentioned the biocarbon side of it. Um, Oddly enough, there is a system whereby which you can tell the amount of carbon in a material, and we go to 105%, which seems a little odd, but the methodology that they use is oddly enough is that after the atomic age, the amount of carbon has increased. Um, don't want to go too deep into the woods of it, but yes, we are 100% bio-based according to um, the federal government and the testing that we have had done. And another part of that is just this spring, the state of Massachusetts uh, made a change in their energy code, their stretch energy code, where if you use the ERI, the energy rating index, and you have a particular component
mm,
that is zero to negative global warming potential. And one of those materials is your thermal insulation package. If your thermal insulation package is zero or negative global warming potential, you can increase your ERI number by 3.
mm.
So instead of having to hit a 55, you can hit a 58. And cellulose is listed as one of those materials. So it's as far as thermal insulation is concerned, it is the one that starts negative and continues to go negative when you start bringing in operational carbon.
Yeah, no, I'm really glad you brought that up, and I was gonna jump to something real quick. So this was or is one of our members' projects. So they were doing our Green Star certification, which requires the evaluation of your embodied carbon, and it requires the reduction of embodied carbon at higher levels. So if you look at they use their beam calculator here, and if you
Mhm.
look at the very bottom right there, you'll see cellulose loose fill. I think they used it in their attic, showing up as a carbon negative material. And so that helped them, achieve a higher level of certification with having a cellulose. In this case, it was blown in, not necessarily rigid, but I assume the feedstock's the same in many cases, right? So you're still getting a similar result, right? Um, as far as carbon reduction goes. But anyway, this is just an example of one of the projects we worked with. I like how you took it further and said, these embodied carbon reductions are getting built right into our energy modeling software. And we're going to be doing some more trainings on that concept where you just get it all. You just have someone go through and they don't have to do a separate like about, engineering evaluation like this one was. It's all just generated right in there, and I didn't even know that that actually helped contribute to a reduction in your score. That's new information to me, so that's pretty cool to hear. So I just wanted to show that part off, but that gets me back to the um um again the baseline material. So you had mentioned the federal government. So if I understand right, then these cellulose typically are getting approved for the I think it's EPA bio-based. Is that the
That's correct. Yes, we're part of
yeah,
the bio-based USDA bio-based program. Correct.
USDA, yeah.
Yep.
Yeah. No, that's really great to hear. I wasn't aware Cellulose was making those. And so those are um uh another example of a point I'm trying to get to here for some of the questions that came in. But one other thing is I remember I wanted to ask first before I got to that point was the blue jeans. I remember
Mm.
there was always the blue jean drives, right? We're collecting blue jeans, we're turning it into insulation. What's going on with that?
So that company went under,
Okay.
but did not go away. Somebody else, another larger group, has resurrected that. So you will see those come back out.
Yeah.
But that material never went away. We will still use that material. We have bales of that denim in our warehouse for other products.
Okay.
Yeah, so it's a very viable, very useful material,
Yeah.
still there. But you will see the blue jean bat come back.
Okay. And is that sometimes also both the um pre and I get the terms mixed up, but post-industrial or post-consumer. So either it's blue jeans coming from the actual consumer or just leftover parts that didn't make it in the factory. Do you get those too?
Yes, it's typically what we call post-industrial in that
Post-industrial.
it didn't make it through their production,
Yeah.
and instead of them throwing it out, there are there are collections, there are brokers that will look for areas of collection of consumer materials as well.
Yeah. Um, so yeah, the larger point I was trying to get to, because some of the questions and conversation going on here was asking, how is cellulose green, or how can it really be that green based on the material? And so I wanted to answer the question first, the question being posed by several people in that typically green, of course, can be subjective to the program that you're looking at. So again, if you ask a wide question like that, it's hard to answer because we don't know what program you're looking at. But if you're looking at, let's say, lead as a great example, where you get points for certain attributes of a product. And I'm saying this to everyone here. I know you know this stuff, Robert, but there are points available for post-consumer as a percentage or post-industrial as a percentage, or even the bio-based certification. So it sounds like in many cases, cellulose is kind of ticking all of those boxes, all of those sustainability boxes. So then it's really on whoever the eye of the beholder is that a sustainable product or not, you know? So just to leave it at that, I guess. So
Yeah, so for us, it starts with the actual manufacturer. The
mhm.
feedstock is saved from going to a landfill,
Yep.
and the energy used to make the material, it gives us the lowest embodied energy. So we don't have as much of a hill to climb when we start talking about operational carbon and getting that energy back.
Right.
It's, yeah, like I said, it is the lowest embodied energy. So there's several different facets that make it either sustainable or green or however you want to label it.
Yeah. Well, and on that note too, I think of waste diversion. So obviously during construction, that's one aspect where you might generate some additional cellulose waste. And I've known like in the blown in aspect, some of that can be, if it's in okay shape, you can take that and use it on the next job, right? I mean, you tell me if I'm wrong. I don't know how that works though on the rigid aspect. Like if you have more than you need and you can't use it for something else, is it recyclable otherwise, or how does that work?
So just the plain cellulose, if you're using the damp spray system, it's recycled back into the vehicle. There's
Right.
no waste. Net and below basically the same thing. But when
Yeah.
you start talking about the board stock and the bats, from a practical standpoint, I'm going to say no.
Oh,
We
okay.
here during manufacture, our
Yeah.
trimmings and whatnot do go back in and are recycled. If the installer wanted to package the cuts and whatnot back up, they could. Depending on the project,
Hmm.
maybe they just end up in the attic on the attic floor for more insulation. They
Hmm.
don't necessarily have to be thrown away. But I'm not going to say that, oh yeah, all of your cutoffs can come back here and we'll gladly accept them and recycle. Sometimes that's more of an energy waste than disposing them, right?
Right. Yeah. Yeah. Um, And then, looking at the sort of do-it-yourself nature of the products of the bat, if I understand correctly, and at least this was, my experience, is it was saying, hey, if you send us what you need and what your specs are and your how many cuts you need and all that. A lot of that stuff could be pre-cut and sent out. Is that something is still being offered in general? Or are you still really relying on the field and people to do that, or is there a hybrid approach to that?
So we can alter the lengths.
Uh-huh.
Um, so if you have a taller basement, you don't have
Yeah.
to have an 8 foot sheet. We can do 10 foot sheets.
Hmm.
Same thing with walls. If you had a 10 foot wall, we can alter the lengths, but not so much figuring out which each, if you have cripple studs that you need these lengths and that type of thing. We can't really put a kit together, let's say.
Yeah. Yeah. Um, as far as the air sealing component, when this is being obviously being installed in most cases against an air barrier in one way or another. Um, what is typically advised for air sealing behind these kinds of products to be more effective?
As your standard construction would allow. I mean,
Hmm.
the what's nice about it is that compression is not going to affect the R value.
Okay.
So we recommend leaving it proud and then
Mhm.
forcing it in to help with that air seal.
Okay.
But it is still subject to the installer if they do not get it cut right, correct?
Hmm.
But elsewise, it's typical. There is nothing different with this than there would be any other type of a bat product.
Okay. So there's not any like recommendation to use something over something else as far as
No,
the air
no.
sealing. Okay. Um, uh, And then some of the other questions were, on the moisture risk of this installation. And so one of the questions was, how much does the insulation blanket wick water if there's water intrusion? I don't know if water wicking is put on a scale of 1 through 10 or what, but how you answer that. So,
Well, so actually, that's not such a bad thing to have happen.
uh-huh.
Instead of it cooling and potentially rotting the wood, it can actually pull it away like you would take a paper towel on a spill. And
Hmm.
now that you have wicked that water or spread it through capillary action and
Mm.
absorption, it now has a greater chance of being able to dry. And even through the drywall, now that it's spread out, it has less chance of doing damage. And with the borates being the primary fire retardant,
Mm.
borates are also antifungal and wood preservative.
Oh, okay. Yeah, with borate. So, um, another question is, what is the name of the airlay equipment that's being used? I don't know if that's like a brand name or what specific question that is, but does that make sense?
It does. The equipment is proprietary, so I'm
Okay,
not, yeah.
fair enough. Um, the next question is, um, well, someone else was trying to compare the rigidness of it. And so obviously the things we can compare it to that I think many are familiar with, like they mentioned, of course, a mineral wool vat. There's you mentioned hemp, and so gave some examples on that. There's foam. So I guess can you just try to compare the rigidity of it a little bit there?
Yeah, you're on par with rock fiber
Okay.
for the
Nice.
bats and the blankets. The inch and a half blanket is more rigid than a rock fiber bat would be, but the rest of the materials are on par with rock fiber bats.
Okay. Um, Another question came in, I think, on your example of the church basement ceiling. And they were asking, is there any other finishing placed against the bottom chords of the trusses? And if not, what level of fire resistance does the exposed batting offer?
So the fire resistance is only applicable to wood stud wall situations where it adds 15 minutes.
Hmm.
So this does not contribute, but it does not necessarily add.
Hmm.
Um, Through our testing, I mean, it did work in the covering of the EPS as a thermal barrier. So in all likelihood, it does, but I can't contribute anything to it because I don't have testing to back that up.
Hmm.
Um, Not sure I understood the question about the bottom chord. What
Yeah,
is
well, we'll have them follow up if they want to elaborate on that part. So
okay?
yeah, I
Okay.
did not either. So um the next question was soundproofing, and they were wondering the STC or any other type of rating that it comes with.
So STCs are all assembly specific,
Oh, yeah.
and we do have an STC of 50 in a 2x4 steel stud wall with 5/8 drywall on either side. So it gives you an idea for an STC. Now the NRCs typically are anywhere from 80, depending on the thickness, to 1 to 1.5, 1.05.
Mhm. Um, and then the question coming in about utilization of the bat cellulose on roof rafters or against the underside of the roof, and if it can be used there, and if it needs a moisture barrier or impermeable materials to prevent possible condensation under the underside of the roof.
Yeah, code is going to require an air impermeable insulation to a specific R value depending on your zone. And
Hmm.
we are not an air impermeable insulation. So you could conceivably put that first few inches of air impermeable above or below the roof deck and then finish with um, this material. In
Hmm.
fact, we did do that in Fort Bragg when we were doing some testing with Oak Ridge National Laboratory on phase change materials. We used the cellulose batt because it made it much easier to swap out. They wanted to know what layer the phase change material should be in. So putting the batts in was much easier. Now that was far enough south that we, at that time, were not really concerned with the moisture against the roof deck. But again, you have to go back and follow your codes.
Yeah. And then the other one is asking if the bats can be used as an ignition barrier layered over the XPS foam board. And if so, how thick would it need to be?
So we did have that tested for the precast basement wall, and yes, it did work, but we do not have it listed just simply outright as continuous over EPS.
Hmm. Hmm. Um, and then the other one they're asking is for an above grade wood frame wall. Do you recommend a vapor barrier to prevent condensation in the wall cavity? And this is a specific question to zone 5.
No, we do not. So in the cellulose industry, we have fought against that vapor retarder
Hmm.
issue for a long time. And as most of you probably know, Joe Steebrook spearheaded that whole change where, now look at what zone you're in, look at what your construction is, and look at what your type of vapor retarder is. And we followed that. So
Hmm.
generally speaking, no, you're not going to use a vapor retarder in zone 5.
Hmm. Hmm. Um, Another question is what's the density per cubic foot?
The bats and blankets are about 1.8 to 2 pounds per cubic foot.
Hmm. Um, And so there was so there's a question on the do-it-yourself aspect again, and this question kind of went even further into the do-it-yourself world, and they were asking whether there was an opportunity or you would foresee anybody actually being able to actually make the installation themselves. I mean, is that it sounds like that's not something that's going to be simple to do, right?
Yeah, no, because of that bicomponent fiber and the compression and the heat, and I don't see how you're going to, considering what we went through as an industrial facility to do it, I don't see how it could be scaled down to where it could be done at home, shall we say?
Yeah, yeah. But then also to clarify, of course, the idea of this product being a little more do-it-yourself friendly compared to other applications. But of course, someone specifically wanted to know, well, hey, if I do want to hire a professional to come out and, I reach out to them about this, is the likelihood that more professionals are offering alternative approaches and not this, um, and is it really more in the do-it-yourself market that's doing this, or is it still more licensed professionals who are, offering this as an installation opportunity?
So the blankets in the basement, we're finding many installers doing it. It's a
Okay.
great option for basement insulation.
Mhm.
But as far as the bat is concerned, we're seeing that as more of a small scale do it yourself. Uh,
Okay.
yeah.
Yeah. And so is that probably saying then, if you're looking at it from a new construction versus renovation standpoint, it's probably being more utilized on a renovation aspect?
Yeah, renovations, we have the installers will carry it if there is an issue after the fact with a plumber or something like that. But generally speaking, it is, yes, renovation, small add-ons, small additions, that type of thing. It's more economical to do either net and blow or damp spray to full new construction.
Yeah. Well, I'm glad you mentioned economical because that kind of gets into the other question I want to bring up, and that is really just trying to compare briefly the costs of these different systems. So of course you've got the cost of batt versus blown as one conversation topic, but then the cost of right, your mineral roll versus your cellulose versus your fiberglass. And then, of course, there's all your other specialties like hemp and wood and all that. So can you just generally speak to the overall cost comparison of this, rigid batt one, as it relates to those, other products?
Sorry, Brett,
Yeah.
but I'm the technical guy, and
Yeah,
I
yeah.
do my absolute best to stay out of sales.
Yeah.
So I mean, I do know the bat is what we list as a premium, and when I hear the word premium, that means it costs more.
Right. Yeah. And I think as you mentioned before that, you said, people are typically using the blown in, like you mentioned, in the blanket, and then using this as just sort of an add-on. So I guess that kind of answers the sort of blown in versus bat conversation, right? I assume though, just from like a labor intent, if you have more labor, you have more cost, right? So
Correct.
just from a
Absolutely.
labor intensive standpoint, it always seems to me bat just lends itself to more labor intensity in general. Is that true?
Yes, you're absolutely correct.
Yeah. Okay. Um, well, great. We still have some more questions. If you stick around for a few more.
Sure.
All right, yeah. But before we get into those questions, just a real quick reminder that yes, this session is being recorded and we will post it in the next week, hopefully, on our YouTube channel. You can either wait and check back then, or you can go there right now at the link below here, click subscribe, and then ring the bell, and you'll get an instant update when the session is posted. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate and you'll receive your continuing ed. For those of you here today, and as long as you've been here for the entire CEU hour, you'll be approved. And then you need to check your spam over the next couple days for certs at gutenbergcerts.com to receive your certificate. And then make sure you also take the survey that pops up when we close out or is sent to your email from Zoom and give us your feedback on this session. We'd love to hear it. And you can report your AIA there as well. And before we get into the rest of the questions, just a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and our nearly 500 members. We're trying to get to 500 by the end of the year in celebration of our 25th year anniversary. So I hope you can help us get there. And our sponsors like Build Equinox, Serve, Tamarack, and Timber HP, who help us decarbonize and meet more sustainable outcomes in the projects that we are doing. All right, so yeah, jumping back into some of these other questions that came in here. So you were talking about a future innovation of the exterior wall assembly, and tell me if I'm wrong there. And so I'm assuming this person heard you say that, and so their specific question is, would that also be good for external insulation on common brick walls?
Yeah, if I can get, I got to have a couple of testing hurdles I've got to get over,
Hmm.
and fire is the number one.
Okay.
And once I can get past that fire, it would be a replay. It would be on par with um, all of your current exterior sheet goods for insulation.
Hmm. Um, yeah, and we'll make sure to have you we'll have you back out once that's up and running to
No
educate more
pressure
people on it,
there.
right? So yeah, yeah, or we'll get the word out. So the other question was on the bore rate, and the specific question was the antifungal aspects of the bore rate. Do you know the longevity? How long those last?
Yeah, it's a mined mineral, and there was some longevity testing done by Oak Ridge, and once they went past a simulation of 300 years,
Mhm.
they ended the test figuring that 300 years was probably enough.
Yeah.
And what they were looking at was potential humidity issues,
Mhm.
sublimating it, and temperature issues, sublimating the chemical out of the material.
Yeah. Well, speaking of 300 years, that kind of gets into, I think, our last question that, oh, well, another one came up here, but I'll still ask that, thinking of time, right? So the question here is, perhaps um, the compostability or the recyclability at the end of the life of a project where you're taking the insulation out. Um, is there anything that can be done with that, or is this, where would this be heading at the end?
Depends on how you harvested
Hmm.
the used material. Um, it could be repurposed into I'll think of any type of paper mache item where you add some starch or some other type of glue and you can form it. The borates that are in there would not allow it to become like peat pots for plants because
Hmm.
it's just a little bit too high for plants. Um, More often than not, it gets turned in with the rest of the debris of whatever is coming down and you can't separate it out. Um, the beauty of it is it does compost fast. So when it gets wet, it takes up very little space.
Hmm. Um, Another question that came in was, as we shift construction towards prefabrication and modular, does, these rigid bats lend an opportunity to just really ship them over to a factory and then they're just prefabbed right into the wall, or into like as a part of a modular component? Are you seeing anything or having conversation on that?
That is one of our customers, as a matter of fact. It is being done.
Great.
It's completely automated. Each cavity is, I don't know if it's sonic cut or laser cut, how the bats are cut, but they are measured on site, cut, and robot puts them in place.
Hmm. Cool. Yeah, that's great to hear. So, well, I don't see any other questions right now. But really appreciate your time for coming out, and thanks to New World too for having you out and all the work you all are doing. And thanks to you all for joining us. We'll be back on same time, same place next week for our show next time. So, thank you all. Thank you, Robert. Take care, everyone. Be well.
Thanks, Brett. Appreciate it.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.